Hello, my name is John Chryssidis from the University of Buffalo, and I'm going to be talking today about ontologies for space and ground systems cybersecurity. I'd like to also thank Barry Smith, also from the University of Buffalo, as well as Alex Cox and Ronald Winnicki from Kubrick, which is the University of Buffalo's non-for-profit agency. So why space cyber? Well, obviously our world relies on satellite systems, and some examples include obviously GPS, science missions to study the universe and the Earth, and also defensive satellites to monitor adversarial tactics. NASIC did a really nice job describing the cyber threats to space systems. So you have the space segment, which includes command intrusion, payload control, denial of service, and malware. There's also the user segment, which includes spoofing, denial of service, and also malware. The link segment includes command intrusion, spoofing, and replay. The ground segment includes hijacking, hacking, and malware. So for space segment, if you hack into a satellite, you can turn it so that the sun is no longer hitting the solar rays and essentially kill that satellite. The ground segment is interesting because there's lots of ways you can hack into a satellite, but from a ground station point of view, you have temporal and spatial issues. So if you have a satellite in low Earth orbit, you can only look at it for a few minutes with one ground station. If you have one in geo orbit, you can look at it all the time, but there's only a few ground stations that can look at it because of the observability of it. So some interesting issues that differentiate from any kind of other cyber system. So we're looking at ontologies for space and ground system cybersecurity. What this does, it provides an effective means to protect satellite assets. To do this, you really must provide a clear and effective dissemination of complex information to end users. So what we're trying to do is take human knowledge and human language and put that effectively into a computer. And to do all this, we must tackle it from a holistic approach. What ontologies do is they provide precise definition of the terms and relations used in the space domain. They're necessary to ensure the consistency across the complex systems of the space cyber defense and threat mitigation as well too. So this allows members of the space cyber community to across the globe to officially communicate on the basis of a shared understanding of terms and also a common basis for exchange and analysis of data. So Kubrick with UB developed a suite of 5 domain ontologies. They're listed right here. It includes 800 plus defined terms specific to the space domain to provide a comprehensive coverage. And this is successfully used to integrate space data by multiple projects. Here's just an idea of the import structure of the Common Core cyber and space domain ontology extensions. So at the bottom here, you got the spacecraft mission ontology, and you can see you got the space ontology, spacecraft ontology, and also military planning. This goes into the spacecraft ontology, goes into space object ontology, and it starts to spread out like this. All of this, all core ontology. And then, so we put this all together to come up with the overall ontology structure. The goal of space ontology is a number of things to support SSA for a number of aspects that I list here. And this is also accomplished by providing a structured common vocabulary to represent the space and ground system domains. In terms of annotating data, also integrating multi-source data using mappings. So here I have a diagram to talk about, there's basically 2 aspects. There's a reactive, which is a lot of what's done right now. You hear a lot of times that a cyber attack happened after the fact. What we want to get to is proactive. And there's a lot of interesting issues associated with that that come straight from data and information fusion. So a lot of, for example, you can have centralized versus decentralized nodes. There's also sensor intelligence versus the bandwidth, how much you're getting. A lot of neat things going on here. To get resilient against adversaries, you got to develop multifunctional strengthening methods. This includes redundancy and repetitions and other things like this. So it gets really complex pretty quickly. Just to give you an idea of how complex it can get, this is just one satellite that goes geostationary operational environmental satellite. It takes all the weather images that you see. And just to give you a spattering of how complex this can get, it's really there. Okay, so some examples again for cyber ontology. It conforms to the common core ontologies, and have a use case here to predict cyber attacks of awareness of software of vulnerabilities. Also used existing knowledge bases from MITRE as well too. In India, we had a systematic model for describing the prototypical attack patterns. Just to give you an idea, this is a cyber attack to encrypt data via privileged escalation. It's also pretty complex. And I hope we talk more about this. Thank you.